And welcome to my channel. So in continuation to learning Docker, today we'll gonna learn about a very important topic called Docker network, right? So in this topic we'll see how containers interact with each other. So intercommunication between the Docker container, how it happens. So we'll see. But before that, I would like to tell you that if you still not have subscribed my channel, please subscribe it and go through the previous video. So we have around 7 lectures describing each and every topic. I tried to explain it very well, so you gain a very good knowledge if you go through all those lectures. And okay, that's all. So let's get started. So in this today session we'll see like the concept of Docker networking, like how packet travels around the Docker container, like how to check the ports on which container is listening, and how to check the IP of the container, IP address of the container, right? Okay, so uh, we can understand the concept of Docker networking through one diagram. So let me draw it for you. Okay, so when we are connecting through any public network, right? So suppose that this is one uh, this one is say one public network, sorry. Okay, so this is one public internet, right? And this I have connected to this public network through say some firewall, right? Some gateway. So in my system it is like Ethernet firewall, right? So whatever communication happens from outside world, it basically routed through this firewall, and this firewall basically a NAT based firewall, which is a network address translation based firewall. So that means that all the internal processes or internal devices which is connected through this firewall basically have their individual IPs, and which is uh, that is at this firewall, when the traffic goes out of this particular interface, it's translated to my public IP, right? Okay, so when we create a container, so what actually we are doing is like that container will automatically connect it to some Docker network, right? Which basically create connected to some virtual network. Okay, let me explain you. Suppose I created one container C1. Okay, so this C1 network, C1 is a container, and another container say I have created, which is C2, right? And this C2 and C1, when basically we create their instances, it automatically connected to some network, right? Which we call as a bridge network. Okay, so these two container, as they are connected to the same network, can communicate with each other, right? Through their exposed ports. So any communication happens if we expose any port on this container. Say suppose this is HTTP server container, so I have exposed port number 80 on my host. This is my host, so I have exposed this port on my host to port number 80 on container C2. So whatever communication happens, that traffic goes out will basically go through this network and then through this particular port. Okay, so suppose I created another, this is the default network, right? So we can create our own network as well. So like I create my network, say this is my network, right? This is my network, right? So I have connected another container, say C3 and C4. Okay, so C3 and C4, these are two different containers which basically connected to this network. Okay, so what actually we do in in production or in a real world scenario is that we we basically create a common network for all the related apps. Suppose this belongs to MySQL and this particular container belongs to say Java, right? So and they frequently interact with each other. So we mention them or we connected them through common network which we called as my network, right? We can name it any other network also. And suppose there is another set of applications, say PHP and Node.js, that frequently communicate with each other, right? So it's ideal way to run those container on some common network, right? So it doesn't mean that C2 and C3 cannot communicate with each other. They can communicate with each other through their expose port, but it is very less, like its frequency is very less, so let's keep it in a different network, right? So this is basically the concept of internal network inside the Docker container, right? Okay, so now let's get into the practice. Let's open the terminal. Okay, so I hope, let me increase the font. Okay, okay, so I hope now it's fine. Okay, okay, so what I'm gonna do is like we'll create two containers for HTTP Apache HTTPD server, which is a web server. So we'll create a two different container and we'll see like how uh, we can uh, assign a common network to those two containers, right? So we know that how to run the container, right? Simple, like Docker container -d is for like running the container in detached mode, that means in background. And let's keep it as the name of this container as web server, right? And let me give it the image name as httpd. We already covered in the previous video. If you have any doubt, like you can refer my previous video. So if I press enter, oh, something happens. I think command is docker container d hyphen name. Okay, what it's saying. Oh, we forgot to mention the run command, docker container run. Okay, so docker container run -d name. So we want to start, this is the image name, so we want to start one container. Okay, cool, container started. So let's run docker container ps. Okay, so the web server container is up and running. Okay, so let's see what all network we have in our currently in our system. So for that we have command called docker network ls, right? So by default you will find these three entries if you have not created any container. So these are bridge, host and none. So we'll cover like what their individual meanings are in some other video, but for now considering that like whatever container we will be creating, if we are not assigning any name for the network that will be assigned to bridge network, right? Some people call it as Docker 0 network as well, right? So now let's create one network, our own network. So for that the command is docker network create, right? So what it will do, it will create a new network. So let's keep uh, the name of the network is my network, my underscore nw. Cool. So it has created one network. So if we run docker network ls, see, we have another new network which is my network. Okay, so now let's run another container, say docker container run hyphen d hyphen name, right? So let's keep its name as web server 2 because web server is already assigned to container, right? And let's assign a name of the network as well this time, right? So we can do a web server 2 network, and the name of our new network is my underscore nw, right? And name of the image which is httpd. Okay, something oh, the name of the spelling container spelling is wrong, so let's correct it. Okay, so our container is up and running. So let me write one command, docker container ps. Okay, so both our containers are up and running. So what we can do now is see what networks currently exist in our system, right? Okay, so we have my network. So there is one command to check like what what are the containers, or what all containers are basically currently tied up to that network, right? So that is a docker network inspect command. So for that we need to run docker. I know it's there a lot of command, but if you practice it will be very easy for you guys. Docker network inspect. So the name of our network is my underscore nw. See, it will give you output in a JSON way. So in container it says like in my network you have this container, okay, and its IP address is this, and so but if I write if config, say that is I think docker if config ethernet 0, I suppose, sorry, yeah, en0, right? So from that you can see like my IP address is this, but it is showing the IP address is this because this address and this address, this is my public address and this is actually the subnet address behind the firewall, right? So this is a common like if someone asks you like, or most of the people thought that whatever IP address is of our local machine, the container will also be having the same IP address because they are on the same network. No, the containers have their individual private networks, so they have different addresses, and which is different than our own address, IP address. Okay, cool. So now we have two containers up and running, and both one is belongs to the default bridge network, and another belongs to uh, our own new created network. So let's do docker network inspect right? And the bridge network, which is the default, so it should be showing the web server, right? See, web server. And if I write docker network inspect my underscore network, so it on this network we have web server 2, right? So it's not always that we have to create a new instance of the container to assign the network. There is one simple command also, which is like a docker network connect or disconnect, right? Suppose I want to connect a web server also to our own created network, right? So docker network connect my the network name and the name of the container. Okay. Okay, so if I do docker network inspect my underscore network, so see, this has now two container, web server and web server 2. Okay, now they have, or they belongs to the same network, so they can communicate with each other easily, right? So that is the purpose of aligning the container, same purpose container, so that they can communicate with each other. If they frequently communicate with each other, so it's ideal, it's a good practice to keep them under the same network, right? Now if I do docker, I want to ping, right, uh, from one container to another, right? So if I do like docker container, I want to open the terminal, so I in the interactive mode, so I will do web server, right, and will do ping web server 2, right? So docker container execute, open the terminal, and web server ping web server 2. Okay, so it's like uh, we have a DNS resolution also available for the docker containers, right? So when we do a ping, we either give the IP address, right, or give the host name, right? So in case like we don't have provided any specific host name, so what docker does, it gives the name of the container as a host name. So when we do what in this part of command we are doing, like we are saying like open the uh, terminal for this particular container, and from that terminal ping this container, right? So let's see, it says that ping doesn't exist. Okay, so you might also get this error because this container doesn't have the ping executable path. No problem. So what we can do is we can go to the bash sorry, I need to remove. Okay, in web server we need, okay, so we are under the bash and we need to install the package for ping, right? So we need to run this command apt get update. Okay, it will download the required packages. So once I have the apt get, then using that I can install one package called iputils-ping. So what I will do, apt get, then I will install iputils-ping, right? Say yes. Okay, so now I have the ping command installed on my container. Okay guys, so let's exit from here and run that command ping. Okay, so I'm opening the terminal and I want to ping from web server to web server 2. See, now we can ping it, right? So docker container, not container, so if we do network inspect my underscore network. So we have these two container, right, on the same network, right? Now let's do, I want to remove this container from this network. So what I will do is like docker network disconnect, name of the network, and web server 2. Okay, so if I run inspect command again, so see, only web server belongs to this network. And now let's run the ping command. I'm sorry guys. So now let me run this ping command again. See, it it says that web server 2 or name of service is not known. Now why we are getting this error? Because they are not in the same network, right? So if I again connect web server 2 to this network, and now let's inspect. Okay, web server 2 is a part of this network, and now if I ping this web server, see, it is pinging. Okay, so I think now we have a understanding like why same type of containers should be in the same network, and if they are in the same network they can communicate with each other, right? Okay guys, so I think that's all from today's. So okay, bye bye, thank you.